Hello, meteorologist Brett Anderson here in the 1011 Weather Center. We are going to start our 1011 Weather Workshop in less than 2 minutes. We're going to be doing this, talking about the water cycle today. So just want you to get ready and have your questions ready after this presentation. So we'll start here in at 1 o'clock, about a minute and a half. All right, welcome to another edition of the 1011 Weather Workshop, and thank you for joining us once again. I think this is our sixth one that we've been doing so far. I know we've been covering lots of topics, and we're going to be covering something very important when it comes to weather, and really for all of us and for life on Earth, and that is the water cycle. So we're going to go through some details and exactly what the water cycle is. Just want to thank everybody once again for joining us. Want to thank Allo for helping us out with this segment, and hope you learned something today. Again, today the topic is the water cycle, and we're just going to first kind of run through some facts, and some of these things you might have known, some things you might not have known. I know some of you might have gone through some of this in one of your science units. So we're going to start off with some just basic facts. 71% of the Earth's surface is water, but only 3% of that total water on Earth is fresh water, meaning the kind that we drink. The other 97% is salt water, basically the oceans. So salt water we cannot drink, so just 3% of the total water once again is the fresh water, and the 97% salt water. So that's a lot of salt water. Now, of the fresh water, 68% of that fresh water is actually locked up in glaciers. So it's frozen. 30% of that fresh water is also underground, which basically leaves 1% of fresh water in rivers and lakes and ponds and streams. So basically you could say surface water. So 1% of that water, of that fresh water, is what we see on the rivers, the lakes, and the streams, so ponds and things like that. So something to keep in mind as we go forward. Now, how long has water been on Earth? There's a couple of theories. Of course, we don't know exactly for sure what happened, but the water may have developed on the Earth as it was forming over 4 billion years ago. There may have been, as the Earth was coming together, all the gases, there certainly may have been water involved in that, and as the Earth formed, the water was there. Another possible theory, or maybe these both worked at the same time, was that actually comets, and you know comets are actually made of ice, water ice, and other materials, but they do carry H2O, water, and there is a theory that over many years, that all these comets and asteroids have some ice in it too, that were hitting the Earth, and the early formation was actually transporting ice, or I should say water, to the planet. And then, of course, with our gravity, it held that water in place, so it was not allowed to escape. So those are the couple of theories of how the water actually got onto the Earth. And again, we'll move on. Now, Here's an interesting fact. Maybe you didn't know this. There is roughly the same amount of water on the Earth as there was 4 billion years ago. So we haven't really seen a gain in water since that time, or we haven't really seen much loss in water. Very, very little has escaped into outer space. So basically, we have the same amount of water on the planet that we did 4 billion years ago. And listen to this, when you drink water, when you take a glass of water right now, if you will, you could possibly be drinking the same water that a dinosaur drank 65 million years ago. Is that impressive, Brandon, or what?
It is very impressive.
Yes, Brandon Rector is here with me here, helping us out. So that's right, 65 million years ago, this dinosaur that you see here was maybe drinking some water. We should come up with a name. I have to thank meteorologist Jan Reichert for making these graphics. She found the dinosaur there. So there's just something interesting to think about, that T-Rex taking a drink 65 million years ago, and the water I had this morning could be the same thing. Maybe even think about this. Maybe even you had the same glass of water this morning that Abraham Lincoln had, or George Washington. It's possible, Brandon.
It is possible.
It is possible. So just think of that. That's kind of a crazy thought. All right, we're going to move on now. Now, some of you may have had this in science, and you eventually will if you had not, but we'll just kind of talk a little bit about this. The water molecule, which of course we can't see the molecules, we can't see the atoms without a microscope, so this is microscopic. The water molecule is actually comprised of 2 hydrogen atoms and 1 oxygen atom. So when you hear the phrase H2O, that is actually the formula, the water molecule, H2O. So that's basically what the water molecule is. We're going to talk a little bit about fresh water. We're going to be talking about the solid, the freezing point. You know that water becomes ice or a solid at 32 degrees Fahrenheit and boils or becomes a gas at 212 degrees Fahrenheit. So remember, a gas is something we can't see. So the water, liquid water, as it approaches 212 degrees, it will become a gas. So, and of course, once the temperature drops to 32, that fresh water or that liquid water starts to become ice. It could be ice, it could be snow, and that's what happens at 32. So that's what we're going to talk about now. We're going to kind of get into the changing of the phases, ice, water, and water vapor. So it comes in 3 states, the solid, the liquid, the gas. And again, we'll put a little temperature thermometer up there, if you will. And basically what happens is, of course, once you see the temperature at 32 and start to climb above 32, we have the ice that will start to melt. It'll be changed from a solid to a liquid. All right, now, of course, that's called melting. And when the reverse happens, when the temperature starts to drop to 32 degrees or colder, we start to see freezing. So that's when liquid becomes a solid or ice. Now, when we have temperatures warm enough, we start to see that liquid evaporate, and it becomes a gas. We can't see a gas. It's all around us right now, water vapor. We can't see that. So that is water vapor. But of course, if you see cooling, you actually will see that gas form back into liquid. So those are the kind of the changes of phases that we have going on here. Freezing, melting, evaporation, and then becoming a gas. Condensation is what it's called. So we're going to go into a little more detail on that here in just a little bit. Now, evaporation, how does it work? Now, basically this is kind of the start of the water cycle, and basically you have the sunshine, and you have the sun evaporating moisture or water from the ground, from the ocean, from the ground, from the streams perhaps, from the trees. So you get energy from the sun, and you start to see evaporation. So that becomes a water vapor. The liquid turns into a gas. Again, we can't see it. Sometimes, in the summertime, if go outside and it feels kind of wet outside, feels humid, we use the term humid, that's actually the water vapor in the air. So rising water, that's what we call evaporation. Now, where does it go from there? Well, once we start to see the water vapor lift, we start to see precipitation developing. Once there's enough, and once it turns back into a liquid, we start to see the precipitation. Now, if it's cold enough, that precipitation, of course, could be snow, or it could be rain. Of course, it could be sleet, all kinds of formation. That's what happens. It starts to rain on the land or the ocean, and basically we start the cycle. So what happens? Well, we have the snowfall. If it snows, eventually it melts, or the snow runs off the ground, or it sinks into the ground, and we start to see runoff. And then some of that water goes into the streams, some of it goes into the rivers, some of it goes into the lakes, and as I mentioned, some of it goes into underground. But as the water eventually will head back to the oceans, whether it's from the stream or groundwater, it eventually will trickle back to the oceans. It may take, hundreds, millions of years, but eventually it gets back to the ocean, and the whole process starts again. You start seeing the evaporation. It goes back up, it lifts, it cools, it condenses into clouds, and then we go back to precipitation. So evaporation turns to clouds, precipitation, the rain, the snow, it falls, it eventually goes into the streams, goes into the rivers, goes into lakes, goes into groundwater, but eventually it will go back to the ocean. Now, of course, some of it will evaporate from lakes and streams as well, but basically that's what we have here. One other thing I wanted to talk to you about is transpiration, and that was basically from the plants, from the trees, from the ground, the crops. Actually, when you have to water your grass or you have to water a plant, it's because it actually is losing moisture as well. It's actually going through the leaves, and so that becomes water vapor as well as it leaves the plant. So not only do we have the evaporation, but we also have what we call the transpiration of moisture from plants back into the atmosphere. So again, that's just kind of a quick presentation of the water cycle, and certainly we can go over that. There's a lot of stuff to talk about there, but we have some questions here. Brandon, do you have any good questions from some of the kids this afternoon?
Well, one that just came in, I think it was asked a little earlier. Andrew wants to know if fire could do a fire cycle.
A fire cycle? That might be another. He was asking if there can be a fire cycle. And you know what? There probably is, and that may be another topic for another day, but there certainly can be a fire cycle. You have the material, the wood, or whatever is flammable, that burns and that gets released in the atmosphere, and eventually it can form into something else that someday down the line could be flammable again, could start on fire. So that's just kind of a quick view on a fire cycle, if you will.
One just came in. What does a runoff mean? You're talking about runoff.
Yes, I was talking about runoff. Runoff is basically like water that, let's say, for example, you watch it rain and you're looking at your street or the sidewalk and you see all that rainwater running down the street in the gutter or on your sidewalk. That's basically runoff, and that can happen on the land as well. It can run off the rocks, it can run off the ground, eventually runs off into the streams or into rivers or into lakes or into the ocean. So that's what we're talking about when we talk about runoff. The water's running off the land. All right. Let's see, is there anything else here? All right. Samantha asks, do we drink salt water when we drink from the water faucet? And the basic simple answer is no. Once again, fresh water, we have to have fresh water to survive. Humans, animals have to have fresh water to survive. So we are drinking fresh water. If we drink salt water, we actually would become sick. So the fresh water is very important.
Sarah asks, it's William that actually wants to know, what water state are clouds considered to be?
William asked that?
Yes.
Yes, if you couldn't hear that, William was asking what state or phase are the clouds. Well, actually, clouds can actually be composed of water droplets, liquid water droplets, the liquid phase, or some of the clouds are composed of ice crystals, especially some of those high clouds. And we're going to be talking about clouds next Thursday, about all the types of clouds. But the clouds can come in icy form or a liquid form, so either solid or liquid. So that was a good question, William.
I think we covered it earlier, but what % of the Earth is covered in water? What was the recap on that?
71% of the Earth is covered in water, and humans are, I believe, just under 70% composed of water. You know, Brandon, I was watching an old Star Trek episode, and the aliens on that had never met humans before.
Yes.
And they called us mostly bags of water because we were mostly water, and that's how they could identify us. So just a little interesting side fact on Star Trek there. But let's see if we have any other questions about. Well, Justin has an interesting question here. He asks, is runoff what happened to make the Grand Canyon? Well, now you're actually going into, again, another topic, an earth science topic of erosion. And yes, runoff would be a form of what formed the Grand Canyon. Basically, over millions of years, you had runoff, or you had water become a stream, the Colorado River, and basically just eroded away that canyon. So yes, it is. Runoff, in a way, in a sense, did create the Grand Canyon. Okay, let's see. I'm kind of going back here, some of these questions. Now, Alyssa asked a very interesting question. Do underwater animals drink salt water? Now, obviously, like the fish and the creatures that actually live in the sea do have to consume salt water. But obviously, their bodies and their makeup are different than ours or mammals or other animals on the planet on the surface, so their bodies are able to handle that salt water. But humans or your dog or your cat or birds, they have to have fresh water. They can't be drinking the salt water. All right. Samantha wants to know, do you guys have a song about the cycle? Is there a song about the water cycle? Because if I heard it, it's been a long time.
I can't remember one off the top of my head.
Brandon can't remember one either. If there is one out there, somebody let me know. If not, maybe somebody out there should make one up. Yeah, that's a good idea. All right, you see any other questions on there? Let's see. I see a lot of questions.
Sophia would like to know, how does a rainbow form after it rains?
All right, and that's something we'll probably talk about in another weather workshop about rainbows, but kind of the quick answer is when the sunlight reaches a raindrop, what we call is refraction. And the word is refraction. So what basically happens is sunlight, you have what's called the white light of the colors in a stream of light, sunlight, are all there. What we normally just see with our own eyes is usually the white sunlight, if you will, or the white parameter. So once it goes through a raindrop, it almost acts like a prism, but it goes through the raindrop, and then it's refracted, and then all the colors are visible in that raindrop. So again, that's kind of a fast look. It'd be easier to show you with graphics, but I don't have those made. But I can tell you that in the coming weeks, we are going to have a workshop on rainbows. So we'll have more on that in the coming weeks. So that was a good question. So you'll have to tune back in, Jamie. All right, let's see what else we have here. Okay. Let's see. BJ wants to know, can we feel clouds? Can we feel clouds? Again, you can sometimes feel the humidity, and like as we talked about, and we're going to talk about clouds again next Thursday, but fog, if you're actually in the fog, because fog is a cloud. When the fog is actually on the ground, it's actually a cloud on the ground. So when it's foggy outside and you're walking around, you might actually feel those tiny, tiny, tiny little water droplets maybe cling to your skin or your hand or your face. So in a way, in a sense, yes, you can feel the clouds if you are in them or if you're in the fog. So that was a pretty good question. All right. Let's see. All right. Any other questions here relating to the water cycle? Thank you so much for everyone watching. You've got a lot of great questions. And let's see here. We kind of talked about it. Stephanie's asking, what if you swallow salt water? Now, I think a little bit isn't going to hurt you, but if you were to have to drink a lot of it, you'd be in trouble. Now, imagine kind of this, you may think about maybe a movie or somebody gets lost at sea and they're out there on a boat and they're lost and they start getting dehydrated, they start getting thirsty. You may ask, well, why can't they just drink? Look at all that water around them. Well, you can't drink salt water because it won't It won't quench your thirst. And then eventually, if you have too much of it, it actually will make you sick. So that is why the humans, we need fresh water. Salt water is not a good thing. So, yes, Stephanie, if you accidentally swallow a little bit, I know that when I've been in the ocean, I've actually taken a big gulp of salt water. It's not a pleasant experience, but I was okay. It's just something that you can't have a lot of, and it won't sustain you. It won't keep you alive if you're out in the middle of the ocean and you don't have any fresh water. So that's that question there.
Here's one from Aiden. Very curious about fog and water vapors. Are they the same?
Okay, so who was that again?
This is Aiden.
Aiden wants to know if water vapor and clouds are the same.
Fog.
Fog and water vapor, that's if they're the same. Well, actually, they are a little bit different, but because you can actually see the fog, that means it's in the form of water droplets. Now, if it's cold enough and there's certain conditions, you could actually have fog cling on to things and actually become little ice crystals. But that's, again, another topic for another time. But to basically get to your question, if you see fog, if you see clouds, that is either in a liquid state or a solid state in terms of ice crystals. Remember, water vapor is a gas. You cannot see a gas in the air. It's kind of like oxygen. We're breathing oxygen right now, but we can't see that oxygen. So that is what water vapor is. It is a gas. It is when water from a liquid to a gas. So that is the difference between water vapor and fog. So that was a very good question. All right. Carolyn wants to know, what if we eat a cloud? You know, you could try it, clouds, and we're going to talk again more about clouds next week, next Thursday. But, there is a little bit of dirt in those clouds, little small particles of dirt and stuff. So, it won't make you sick or anything, but, you're kind of maybe eating a kind of dirty water droplet, if you will. Yeah. No. We'll talk more about that next week, of course. All right. So, do we have anything else? Any other great questions? Colin wants to know why clouds are not bendable. Like if you try to maybe grab onto the fog, it's just, because, the droplets, there's nothing really to grab onto. The droplets are there, but they're not really in a solid form. Now, if you had ice, you can obviously try to bend that, or it'll break or shatter, but again, you just can't really grasp onto all the tiny little water droplets which make the clouds. Now, the wind certainly can shape clouds, because the wind will push clouds. They can stretch the clouds out. They can make the clouds go up. They can make them taller. They can flatten them out. So the wind can shape a lot of the clouds because of that. But as far as humans actually physically trying to bend or mold it, that would be really hard to do. It really has to do more with the wind. Okay. All right. Myrna, or Mimna, I don't know if I say your name right, and I apologize if I said that wrong, is asking, is all water at some point evaporated? And it's kind of a yes and no question. It all kind of depends on conditions. So like, for example, if you were to get outside, if you were in a swimming pool, and it was very humid outside, a really hot, humid day. Remember, when there's high humidity in the air, that means there's a lot of water vapor in the air. So if you were to get out of that pool and you don't feel like you're drying off, you still kind of stay wet, that's because there's so much humidity in the air, so much water vapor in the air, that the water on your skin can't evaporate very fast. So that's why sometimes even after you get out of the pool, you don't feel like you're drying off very fast. So again, it kind of depends on conditions. And then on the other hand, if the air is very dry or has very little water vapor in it, and then you get out of the pool, and then that starts to dry really fast, your hair starts to dry really fast, that's a faster rate of evaporation. And if you noticed, when you step out of the pool, a lot of times you feel like it's cold, you feel cool. Well, evaporation is actually what's called a cooling process. So when that water, that liquid water, is evaporating from your skin and your hair, it's actually cooling. It's actually cooling things down. It's actually cooling you down. So that's why you actually feel cold. That's another reason why we actually sweat. Sweating is a way to keep the body cool. We start getting hot, we start to sweat, that sweat starts to evaporate. It's a natural cooling process. But when it's really, really humid outside or there's a lot of water vapor, it's a lot more uncomfortable because that sweat doesn't evaporate. So therefore, we're not getting that cooling process. So basically, it all kind of depends on how much moisture's in the air, what the temperature is. But at some point, may take a long, long time, water that's in the open will eventually evaporate. It may be in the form of ice first, and then it has to melt, and then eventually it could turn into water vapor. All right. Any other good questions during that long explanation of evaporation?
Let's see.
All right. Let's see. Alyssa does have something about why can't we see the oxygen we breathe? And is it water vapor? Well, what happens when things become a gas, when oxygen is a gas, or water vapor is a gas, or even carbon dioxide, what's happening is the molecules are moving so fast, and they're far apart that we just can't see it. We can't see it with our eyes. So that is why, because you have, especially with heating and evaporation, that actually creates the molecules farther apart, they move faster, and that is why we can't see a gas. So the question is, water vapor, it's a type of gas. Oxygen is a gas. It's two different gases. But to answer your question, yes, every time we take a breath, we are breathing in water vapor. We're also breathing in oxygen. We're also breathing in carbon dioxide. We're also breathing in nitrogen. So there's any gas that's in the air we're actually breathing in, but our bodies use the oxygen. We take the oxygen from the air to survive, and then when we exhale the excess, as well as, of course, carbon dioxide, which, of course, the plants love. And that could be another weather workshop in the future called the carbon cycle.
Carol would like to know, what makes rain come down really hard sometimes and sometimes lighter?
And who was that again?
This is Carol.
Carol wants to know what makes rain fall really hard sometimes or not so hard other times. And again, it kind of depends on the moisture that's available. So like if you have a lot of water vapor in the air and it becomes liquid and it becomes the cloud, and you keep on getting more and more moisture in there, and that updraft, Ken was talking about updrafts with thunderstorms the last couple of weeks. So you start getting this updraft that holds all that rain up there, holds all the moisture in that cloud. Well, eventually it gets too heavy and it will overcome the gravity and it starts to fall, or it overcomes the updraft, I should say, and then gravity will bring it down. So that at that point, it's got a lot of moisture, the raindrops are big, and it comes down really, really hard. Other times, there's just not a lot of moisture available, and there's not a lot of a big updraft to make the clouds, so the clouds form a little bit of light precipitation, and it comes down a little more gently. So it all just kind of depends on how much moisture is available, how much water vapor is available for clouds and rain development.
Sandy wants to know, and I think we kind of talked about this a little earlier, you did, can ice evaporate?
Yes, there are a couple of topics we didn't talk about because this is where it actually gets a little more complicated. There is something called sublimation and deposition. Sublimation is actually when you have enough energy that can actually turn ice right from a solid straight to a gas. It actually skips the liquid phase. Sometimes if you have very, very, very dry air and it's very cold, you can actually have ice or snow not even turn to water, it'll skip and go right to the gas phase. And then on the other side of that, deposition is where you have water vapor that becomes a solid. This is best shown when you have frost in the morning, in a cold winter morning. Like we might have frost tomorrow. That never goes into a liquid phase. If the temperature is below freezing, the water vapor in the air will actually form on the car or on the grass, the windshield, wherever's outside, will actually form as ice. So it will actually skip the liquid phase. So yes, to answer your question, there is the sublimation, which is where ice goes directly to a vapor or a gas, and vice versa, the deposition of the gas goes directly to ice. So we didn't get too much into that one because there's a lot of calculations, a lot of math, a lot of energy that takes place during all that. But that is, it certainly can happen, and we did at least get to touch on that a little bit.
All right, let's see. Ben asks, why is water blue? Or why does it look blue?
Why does it look blue? Again, that kind of has to do with the wavelengths of color. And this is something else that we'll probably talk about when we talk about rainbows, is that the color is there. It's kind of almost the same reason why the sky is blue. What happens is the sunlight comes into the atmosphere, and the molecules of a certain size will absorb certain colors, so we don't see that with our eyes. But then when it comes in contact with the blue wavelength or larger particles, that blue wavelength scatters all over the place. It just scatters all over the sky, so that is why it looks blue. And it's somewhat similar with the ocean. So when you look at it on a sunny day, it looks blue. But if you think about it, like on a cloudy day, when it's cloudy, it almost kind of looks just kind of gray or maybe even black. And at night, it doesn't look blue either. So it really has to do more with the sunlight, why it gives us that bluish color on lakes or the oceans or streams and rivers. I think we have time for maybe one more.
Oh, let's see here. Which one should be?
Let's see. We'll take one from Caden. Stephanie is asking for Caden. Wants to know, when rain falls, does it rain all over the world? So Caden wants to know if it's raining, maybe if it's raining here, if it's raining all over the world. And the answer to that, Caden, is actually no. It all depends on where the weather systems are, where the clouds have developed. So some areas it can be raining or snowing, and other areas, maybe just 100 miles away, it's still nice and sunny and warm. So no, it does not rain all over the world at the same time. Some areas get a lot of rain. Ken was talking about that on Tuesday about extremes, and some areas don't even hardly see any rain, and those are usually what we call the deserts, where they see very little rain. So, yep, to answer that question, no, it's not raining at the same time everywhere across the world at the same time. So that's a great question. So I think we're going to wrap up here. If you have any other questions, we'll answer the questions on Facebook here. But again, I want to thank you very much for joining us again. I hope you got something out of the water cycle. Again, this will be available on the 1011 website to review again. So if you missed it or didn't have a chance to see it from the beginning, you can go ahead and check that out on the 1011 website that we have. So other than that, thank you very much for joining us. I believe Ken is going to be talking about perhaps lightning on Tuesday. I'm not 100%.
I believe that would be the next one.
I thought I saw that on the schedule. So he's going to be talking about lightning and how lightning develops and why we have lightning. So that'll be very interesting. That'll be on Tuesday. And as I've been mentioning, next week, since we kind of talked about the water cycle, and we've already talked a little bit about clouds, we're going to actually talk about the clouds and how they form, why some of them are water droplets, why some of them are ice crystals, the different types of clouds, low clouds, middle clouds, high clouds. So we're going to be doing that next Thursday, but before that, Ken, on Tuesday, we'll be talking about lightning. So again, thank you very much for joining us. And again, if you have any other questions, you can always have your question on Facebook, and we will get back to you as soon as we can. So take care and have a great weekend and be safe.